In the case of modern LANs, networks today are pretty much all switches within the network as they, get down to the user level. Now, up towards the core or distribution portions of the network, we're talking about more routing engine type stuff. But today, users are going to be logically grouped into physical locations within the network. And these switches are going to be interconnected via higher speed links to aggregate the user traffic up towards the distribution and core areas of the network. Most of that segmentation is being done today using VLANs. Now, a VLAN, which is a virtual LAN, is really the router's job given to a switch. We haven't talked about routing engines yet and what they really do, but let me give you a brief overview here. On a per port basis, what a switch is doing is it's segmenting the network based on collision domain, just like a bridge did. Each port's a separate collision domain. Now that we've gone to all switches, kind of turning off the whole collision thing because we've gone and done full duplex. In the case of a router, each port is its own collision domain, but it's also a different logical network, meaning in an IP world, a different subnet on every port of the router. That's one of the key rules of routers we'll talk about later, is that every interface needs to be a different logical network, a different subnet. In the case of VLANs, if you were wondering how I was going to tie this together, in the case of VLANs, we've given a capability that's normally reserved to the router to a layer 2 switch. And what we've done is we've given it the capability to segment the network based on logical network. So a VLAN really is a subnet. In the case of IP addressing, it's a different network number on a per VLAN basis. Now, that's normally the router's job. Every port on a router, different logical network. Every VLAN, different logical network. But what we will not give the switch the capability to do, we're not going to give the switch the capability to interconnect those logical networks. Only a routing device, layer 3 router or multi-layer switch, is going to have the capability to interconnect multiple VLANs. So when you are on a strictly layer 2 switch and you've created multiple VLANs, those VLANs can't talk to each other. So if you've got VLAN 1, 2, and 3 on your switch, VLAN 1, 2, and 3 can't talk unless you've incorporated a router somewhere in your network. So you're probably asking, why create VLANs? Well, VLANs, just like segmentation with a router, separate your logical networks and also separate your broadcast domains. So the scope at which your broadcasts can travel is now reduced on a per VLAN basis. It can also be used as a spanning tree tool. We're going to talk a little bit about how spanning tree works in this section and then go into greater detail as you get into ICND Part 2 and talk really how spanning tree works and talk about the commands to support spanning tree within your network. But VLANs today can be used as a tool for spanning tree to allow it to load share your network and utilize the higher speed links that we can use on a per switch basis. So from a switch to switch basis, we're using high speed uplink ports between those switches. We can use spanning tree and VLANs in combination to allow it to load share your network.